Before we do the 2-2 notes, we're going to talk about some basics with graphing quadratic functions. There's a picture of a quadratic function. It's a U-shaped parabola. And labeled are some of the key features. So we're going to take a couple notes on those key features. The main one is vertex, which is the point on top or bottom of the U. The vertex could be a maximum or a minimum. If the graph opens down, then the vertex is going to be a maximum because it would be on the top of the graph while it opens down. And the vertex is going to be a minimum if the graph opens up, where the arrows point up, because that means the vertex is on the bottom. On the graph in my picture, the vertex is on the bottom of the U shape, so this would be a minimum. Next, we have the axis of symmetry. On a graph, it looks like a dashed line. It's invisible, but it's the line that the parabola is symmetrical about, so it's like kind of a mirror line. Everything on both sides will be the same. The axis of symmetry is a line, a vertical line through the vertex. The equation for it is x equals a number, and that number is going to be whatever the vertex goes through, so the x value of the vertex. Your y-intercept is going to be wherever the graph intercepts your y-axis. So in this case, it would be right here. And that is the point where x is 0. So it can be found in an equation by plugging in 0 for x. So to graph a quadratic function, there's just a couple steps to make it quick with no table at all. Step 1 is going to be plot the vertex. Step 2, plot the y-intercept. Step 3, we're going to use A, which you'll see what I mean in a moment, to help us connect the graph. Off to the side, I'm going to have us make a little note about what A is. A is the coefficient for x squared. Think of it as the number that's out front. And it tells us a couple things that help us graph. If A is positive, the graph opens up, which means that the arrows are going to point up. If A is negative, the graph opens down, which means the arrows will point down. And lastly, one more way that A can help us is it's kind of like a slope. It can tell us how steep a graph is going to be, but you can use it to get 2 points on your parabola. So if you treat it like a slope from the vertex, you can use it to get a point on the left and on the right. You can only use it for 2 points, that's it, because the truth is A is not a slope the way that it would be for a line. On a parabola, the slope is constantly changing. But again, it can help us get 2 points. There are 2 forms that you're going to see when you graph quadratics. So vertex form, you'll notice because it has usually parentheses. The nice thing about vertex form is you can see the vertex just by looking at it. So the vertex is going to be h comma k. And it's similar to the shifting that we've done where we shift horizontally and we shift vertically. Basically, that tells us where the new vertex will be. And remember, when we have a number added or subtracted inside the function, we go the opposite direction. Anytime we do a horizontal shift, it's the opposite of whatever sign we see. So that's why there's a negative there. So a quick example would be if I had a function like this, the vertex is going to be change the sign for your x value. So -1, but keep the sign for your y value. So -4. So that's one example of a vertex form equation and how I would find my vertex for it. And by the way, in this scenario, A would be 2. If it helps, make a note to yourself that x value is opposite sign and y value is same sign. There is one other form that you're going to see, and it is called trinomial form. And it looks like the typical equation that you would factor or put in quadratic formula. So it's the normal one that you've been factoring and working with, but the vertex you cannot see just by looking at it. So there is a formula to find your vertex. So your vertex is going to be, well, the x value is going to be negative b over 2a. That's the formula. And the y value is what you get after you plug in negative b over 2a into your function. So you'll find x by doing negative b over 2a. And then to get y, you're going to plug in x value to equation. So that's how you're going to get the vertex in each one. Obviously, vertex form is a lot easier, and trinomial form takes a little bit of work because you have to find the x value and then plug it back in to get your y value. But the last thing that I want to make sure we mention somewhere for each one is your y-intercept. And I'm headed back to vertex form here. We would have to plug in 0 for x. And if we have trinomial form, the y-intercept, we plug in 0 for x, but you're going to see that every single time it's going to be 0, c, because all the stuff with x's will cancel. So when you plug in a 0 to trinomial form, it's really easy. Your y-intercept is just this last number right there. Okay, on the back side of this page, you're going to see two graphs. One of them, we're going to graph one function in vertex form and then one function in trinomial form. So the first one is vertex form, and we're going to do this with no table at all. It's going to be kind of a rough sketch, but we need two main things, and then we will use the front number a to help us connect. The two main things we need are the vertex, and the vertex is going to be -1, 5, because remember, when it's in vertex form, you can see the vertex, you just change the sign for your x, but keep the sign for your y. So that's our vertex. Our y-intercept, we will have to find by plugging in 0 for x. I have -2 parentheses 0 plus 1 squared plus 5. Remember, I plugged in a 0 for x, so my coordinate, I'm going to put a 0 in the x position. And then I've got -2 parentheses 1 squared is just 1 plus 5. -2 times 1 is -2, and then plus 5 gives me +3. So now I can head over to my graph and I can plot both of these things. So I'm going to start with the vertex. The vertex is at -1, 5, and I am going to label it. I can also plot my y-intercept at 0, 3. And this is the part where you need to pay attention to how we can connect this thing. First of all, you only have 2 points here, and we know that we need it to be a U shape. So don't just connect this into a line. We are going to make a U shape, and we need kind of a prediction of how it's going to look. A is going to help us out with that. So if I take a look at A, which is the number out front, so -2, I know that because it's negative, this thing opens down. I should expect my parabola to look something like that. I also can think of it like a slope, but only to get 2 points, because really the slope is not going to be the same everywhere on a parabola because it's a curve. So we can only use the slope to give us 2 points, but my slope being -2 means down 2 over 1 from the vertex. Again, I can only get 2 points. You cannot continue with down 2 over 1, down 2 over 1, because it's not a line. But let's head over to our graph. We know it looks like an upside down U shape. We know that the vertex is going to be on the top of that U shape right there. And if I go down 2 over 1 in both directions, which I actually already have a point there, then I get kind of a picture of my U shape. I'm also going to have you guys make a dashed line through the vertex because this is called our axis of symmetry. And our axis of symmetry is always going to be an equation starting with x equals. And it's x equals whatever number we go through on the x-axis, which is always going to be the vertex x value. So since my vertex is -1, 5, I'm going to go through -1 on the x-axis. So this is x equals -1. So here's my axis of symmetry. Again, it's kind of a dashed invisible line. But the reason it's important is because a parabola is symmetrical on both sides. So if you have a point on one side, you can plot a point on another side to copy it to make it faster. Everything from here, though, is going to be a rough sketch. So do your best to make a rough sketch of this parabola, opening down. And then we're going to finish off by writing a few more key features that you'll be asked for, like domain and range. Your domain is always going to be -∞ to infinity on a parabola. Your range will change because it depends on where your vertex is. So remember, range always goes up and down. It's your y values, it goes up and down. And we always go lowest, comma, highest. So how low does this go is the first thing we want to put, and it goes down forever. The arrows point down forever, so we know it goes down forever. That's the lowest it goes. What's the highest this graph goes on the y-axis? It goes up to 5. Be careful right here because we will always use a bracket at that spot, because if you take a look at our graph, it is solid at 5. There's no open circle there. So we will always have a bracket at that number. So remember, your range depends on the vertex. The last thing you're going to be asked for, because now we have our axis of symmetry, which is important. We have our domain and our range, which you'll always be asked for. We know the vertex. We know the y-intercept. But the last thing that you're going to be asked for is the vertex a maximum or a minimum? The vertex is a maximum on this graph because it's on top. And that is how you can graph a parabola with no table when it's in vertex form. We have one more to do on this paper, and then we move on. This one's going to be in standard form. The way I can tell is I have an x squared, I have an x to the first power. It looks like something that I would factor or use quadratic formula on, and also it has no parentheses the way vertex form does. So remember, your vertex here is not as simple anymore. You cannot look at this and see what the vertex is. You have to work a little bit to get your vertex. So remember, we're going to use this formula, -b/2a, to get our x value. And it would help to list out what A, B, and C are, because we'll be using them. So to get the x value of my vertex, I have -4 over 2 times 1. That's the x value of my vertex. And again, I'm just plugging in A and B. And I get +4 over 2, which is 2. My y value is going to be whatever I get when I plug in my x value, which is 2, to the equation. So for x, I got 2, and now I have to plug that in to get y. So that's going to be 2 squared minus 4 times 2 plus 1, which is 4 minus 8 plus 1. And I got -3. So I now have my vertex, and I did a little bit of work for it. But the good news is, that's the first thing we needed. The good news is the y-intercept is always going to be super easy on this one. If you have trinomial form, then your y-intercept is 0, c. which is 0, 1, because that's the C term. And again, imagine if I plugged in a 0 for all the x's, everything would cancel and I'd be left with just that one. So I now have my vertex, my y-intercept, and let's take a look at A. A is 1, which is positive. So the graph opens up. I know what it's going to look like because I know it opens up. I know where the vertex is and the y-intercept is. And lastly, the slope would be 1. So up 1 over 1 from vertex. So these are all the pieces that I need to be able to graph this thing. Now I'm going to head over to my graph and plot the vertex at 2, -3. And I'm going to label it vertex. Now I'm going to put my y-intercept at 0, 1. And at this point, I would make a dashed line for my axis of symmetry because it's going to help me connect my graph better. I think it helps connect the graph better because it's going to be symmetrical on both sides of the yellow line. So when I plot any other points, I can put it on both sides. My axis of symmetry is the line x equals, well, whatever the x value of my vertex is. In this case, it's 2, -3. So x equals 2. And I can also just look at the graph and see that that is where we cross through. So I've got my axis of symmetry. I have my y-intercept and my vertex. The last thing that could help us connect this thing would be the slope. Remember, we go up 1 over 1 because our a value is 1, and you can only get 2 points. But remember, our axis of symmetry allows us to make our graph match on both sides. So that y-intercept, if I just count some spaces, gives me another point on the other side. Now I'm ready to connect this into a rough sketch that looks like this. It opens up and it has a domain of -infinity to infinity, which it will always have, but the range is what changes. This time it's not going down forever. The lowest it goes is -3. And we can equal -3 because it's solid. The highest it goes is it goes up forever. That would be my domain and my range. So I've got my domain and my range. I have my axis of symmetry. I have my vertex, my y-intercept. And the last thing you'll be asked for is the vertex a maximum or a minimum? Well, the vertex is on the very bottom, so the vertex is a minimum because it's on bottom. Okay, you're going to head to 2.2 notes, and it's pretty short. We're just going to kind of put all of this together and graph a few functions. So in the box at the top of the notes is just a recap of everything we talked about. The vertex on bottom is a minimum, and the vertex up top is a maximum. You've got your axis of symmetry, and then if A is negative, then your vertex is a maximum. If A is positive, vertex is a minimum. And then here's a formula to find the vertex if you have trinomial form. This is just to reference to if you need to. But we're gonna head over to example 1, and we have vertex form this time. So vertex form is nice and easy. You don't have to do any work to get your vertex. It's gonna be the opposite sign of your x value and same sign for your y value. So it's +3, +8. And that's all there is to it. The direction means does it open up or down? And you're going to look at A for that. A is -2. That is the number out front. That is your A value. And if A is negative, then that means that this opens down. which looks like that. And at this point, before I do anything else, I want to make a note that the vertex is a maximum, because now that I know it opens down, the vertex will be on top. My y-intercept is whatever you get when you plug in 0 for x, which I need to do. So I'm going to go -2, parentheses 0 minus 3 squared plus 8. Make sure you're careful with the order of operations here. -2, parentheses -3 squared plus 8 means you have to do the squared part first. You've got -2 times 9 plus 8. You should get -18 plus 8, which is -10. So that took a little bit of work. But our y-intercept is 0, -10. Our axis of symmetry is going to be x equals, every time it's going to be an x equals situation. And it's always going to be x equals whatever number x is in the vertex. So I'm going to color code that yellow because I have my vertex x value already colored in yellow. It's x equals 3. So this number right here tells me the axis of symmetry. And the last thing that I want to mention before I start graphing this is if a is -2, your slope is going to be down 2 over 1. So now we have we have all the information needed to graph this thing. So let's start plotting whatever we can, starting with our vertex at 3, 8 and labeling vertex. We already expect this to open down. We have a picture of it. We know because a is negative. I'm going to also plot my y-intercept at 0, -10, which is pretty far away. So the next thing I would do if you're stuck, if you don't know what to do next to connect this thing, I'm going to make a dashed line for my axis of symmetry. I'm going to color code it the same color as I have axis of symmetry already. That way I know my yellow line corresponds with axis of symmetry, which also corresponds with the x value in my vertex. Okay. I would use the slope at this point, down 2 over 1, to get 2 more points. Down 2 over 1 from the vertex, down 2 over 1 in both directions from the vertex, and that's all you can do. You can't keep going because this is not a line. You can only get these 2 points. But I have an axis of symmetry, meaning it's symmetrical on both sides of the yellow line, so I can copy my y-intercept point onto the other side. You're going to do your best to connect this into a steep upside down parabola. Should look something like that. The domain will always be -infinity to infinity. And the range changes depending on the vertex. So in this case, this goes down forever because I have arrows pointing down forever. So the lowest it goes is -infinity. The highest it goes, well, let's take a look at our vertex to see. Our vertex is at 3, 8. So the highest it goes is 8. Remember, put a bracket there because it is solid at that place. So there will never be a time where you'll put a parenthesis in your range next to the number because our parabola will always be solid the whole time. So parentheses only need to go next to infinity and -infinity when we're doing these parabolas. Head to B, and I want to mention that sometimes it's meant to trick you a little bit to see if you know how to rearrange things so that it looks like the vertex form we've been working with. And this doesn't look exactly like the vertex form we've been working with because we have like this 2+ situation out front. So what I'm going to do is I'm actually going to move my 2 over here just to get it looking like it should. So I've got +1/2 times x minus 1 squared plus 2. Taters, stop it. My vertex, I can tell, is 1, 2. the opposite sign of whatever my x value would be, and the same sign as whatever my y value would be. In this problem, a is 1/2, which is positive, so this graph does open up. So it should look like that, which means that my vertex is a minimum. It's a minimum because it's on the bottom, and I decided to move my words over a little more so it looks a little bit better. Okay, so we've got our vertex. We know it's a minimum because, again, it's on the bottom of a U shape since it opens up. Before I move on, I'm going to make a little note that my slope here is 1/2, so it's up 1 over 2 from the vertex. And I know it goes up 1 over 2 because it's positive. If it were negative, it'd go down 1 over 2, but we go up 1 over 2 to get 2 points. Y-intercept, I'm going to plug in a 0 for my x value. So I should get 1/2 parentheses, and I'm using this top equation that I've already rearranged, 0 minus 1 squared plus 2, which is 1/2 times -1 squared is 1 plus 2. This is 1/2 plus 2, which is 2.5, 2.5. So my y-intercept is I plugged in a 0 for x, I got a 2.5 out for y. That's my y-intercept. And lastly, my axis of symmetry is always going to be x equals some number. It's always going to be the number you can find in your vertex for x. So in this case, it's 1. And I'm ready to graph. I'm going to start with my vertex at 1, 2, and I'm going to label it my vertex. I expect this thing to open up, and I have a y-intercept. This part's going to be a little tricky. A y-intercept at 2.5, really close to the vertex. And at this point, I'm going to make my dashed line through my vertex for my axis of symmetry. So I've got my axis of symmetry. I know that whatever is on one side can reflect onto the other side, so I could put a little point here as well. I'm going to move. This is all so close together, so I'm going to make a little note. My vertex is at 1, 2. Okay, I have my y-intercept, and I reflected it over to the other side of the yellow line because you're allowed to do that. But what else could help me get more points on this thing? Well, my slope says go up 1 over 2 from the vertex. And you can only do that one time. You can't repeat that. But this is enough to get kind of a rough sketch. This is kind of a wide U shape. So it should look like that. Lastly, our domain is always -infinity to infinity. And our range, the lowest it goes, if you look at the vertex, the lowest it goes on the y-axis is 2, bracket on 2. Goes up forever because our arrows go up forever to infinity. So that is how we would put everything together using vertex form. And the last thing we have to do is graph with standard form or trinomial form. By the way, trinomial form is what Pearson uses, but in most textbooks it's called standard form. Okay, I'm only actually gonna do A, and then I'm gonna leave B for you guys to try. So you guys should be doing B on your own. The vertex is the tricky part here. So remember, your vertex, you have to actually work for it. To get your vertex, you have to do -b over 2a. And I should know what A, B, and C are first. A is -1, B is -2, C is 1. So to get my vertex, I've got -2 over 2 times -1. All I did was I plugged in A and B into this thing. A lot of negatives, but when you simplify everything, you should get -1. So my vertex is -1, comma. Well, now I need to figure out what the y value is, and you're going to get that by plugging in -1. So we have to plug -1 into the original equation. When I plug in a -1, I have to be so careful with my negative signs. First of all, you can't cancel these two negatives out because one of them is already being squared. So you have to do the exponent first. We get negative, and then -1 squared is 1. Then I have a negative times a negative, which is +2 plus 1. This ends up being 2 for my y value. And that is a tricky one because of those negative signs. But we have our vertex. We know that A is -1, which means it opens down. So it's going to look like that. And the vertex will be on the top. So the vertex is a maximum. All right, I know my vertex, I know it opens down, and remember the y-intercept here, if I plugged in a 0 for x, everything would cancel except for the c term. So the y-intercept is 0, c, which is going to be 0, 1. And last little note I want to make, just in case it helps me, is my slope to get my 2 points. Remember, we use a for our slope, so that is -1. So slope would be down 1 over 1, because a is -1. All right, we can start plotting. Start with the vertex -1, 2, and label it vertex. Then we have our y-intercept, which is at 0, 1. Make our dashed line so that we know that it's the same on both sides of the dashed line. And in this scenario, I can actually just go to the other side of the dashed line because it's symmetrical and I have a y-intercept. So if I just go 1 over on the other side, I get a new point. And my slope actually isn't going to help me. Down 1 over 1, I already have points there. So I'm ready to connect this thing. That's the best I can do. You could get more points by making a table, and it would be more accurate. But this is kind of a rough sketch with some of the main features. And the domain is -infinity to infinity. The range is going to be, the lowest it goes is -infinity because it goes down forever. The highest it goes, well, my vertex is at -1, 2. So the highest it's going to go is 2, give it a bracket. And that's what our final answer would look like there. The most work you have is obviously finding the vertex because you can't just look at it and tell what the vertex is. So I'm going to have you guys do B, but before you do B, you will have to rearrange so that you can tell what A, B, and C are. I'll do the rearranging for you if you want, just to make sure you've got it down right. Because if you don't have it rearranged correctly, you're going to do the whole thing incorrectly. So I'm going to go ahead and put 2x squared first, +4x next, and end with -3. This is the order we want to use. A is 2, B is 4, and C is -3. And you're going to use that to find all of these key features and graph it.